Hi guys, this is going to be a video about protein translation and transcription. So remember, DNA provides a blueprint for building the proteins in your body. And the way that works is that you have your DNA sequence. Give me a second, sorry. DNA sequence. That gets translated into RNA in the process of transcription. RNA gets fed into the ribosome. And the ribosome is an organelle which takes this RNA and translates it into protein. Okay, and this process here is called translation. All right. And so let's imagine we had a DNA strand. Let's say we had ATG, TCC, TAA, right? Let's say we had that DNA strand. So the first thing we have to do is we have to transcript this DNA strand into RNA. And so the process of transcription is pretty easy. After all is said and done, all the T's in the DNA strand get converted into U's. Okay? Thymine gets replaced with uracil. So, in the original DNA strand, now we have ATG, TCC, TAA. Now we have A, T gets translated into U, G, U, C, C, U, A, A. All of the letters stay the same except for T, which gets transcripted into U. Okay? So that's the first step there. With translation, it's a little more tricky, right? So the first step here, is to find AUG. Find AUG. In this case, we have AUG as the first three letters in our sequence, right? So, great, awesome. It's at the very beginning, so we're going to start from there. After that, the second step is to break it up into three-letter chunks. Break it up into three-letter chunks. Okay, so starting with AUG, we're going to read three-letter chunks at a time, and we're going to break it up as such. AUG, UCC, UAA. Okay, finally, we're going to look on the codon table over here, right? And so this is the codon table. This will tell us how the ribosome is translating these RNA sequences into protein. All RNA sequences start with methionine. Okay, methionine. So AUG translates into the amino acid methionine. UCC, right? So we're going to look in the U row. That's the first letter. The C column, that's the second letter, right? So U and C. So we're going to be looking right here. U and C. Oh, there it is. It translates to serine. Okay. Finally, we're going to look at UAA, UA. So we're going to look where it intersects. UAA translates to a stop codon. And when we reach the stop codon, that's when the ribosome ejects the protein and it gets sent to do its job, right? So we have methionine, serine, stop. That is our protein. You can imagine that with 3 billion letters, we have a lot of different kinds of proteins, but we can break down this transcription, this translation of protein into these steps. Okay? Hopefully that helps. Take care, everyone.